In this section, we will introduce HBase. Let's see what is HBase. HBase is the columnar database that runs on top of Hadoop. It is a distributed database, so data is stored on many machines that we have in the Hadoop cluster. And the data structure that is fundamental for it is something that is called a sorted map. This database has a very flexible schema, so the columns that we have for our tables can be dynamically added on the fly. And the number of columns that we can have goes into billions. So it's a very different architecture than what we have with relational databases. This type of design is often called a wide table or a long row database. One of the great advantages of HBase is that it is a system that is horizontally scalable. It can be spread over hundreds or thousands of machines. And one of the other characteristics is that the data that we have can be sparse, and the HBase can very efficiently store this type of data. Looking into some other characteristics is that it provides strongly consistent reads and writes. It is also a fault-tolerant system, so that one machine that is part of the cluster that is running HBase, the machine can die, and this is not going to prevent us from running computation. So data is stored in the fault-tolerant fashion. Naturally, you will see that when you talk about systems like HBase, which is a representative of NoSQL systems, you will find that the systems that scale very well need to sacrifice some of the other characteristics. And in many cases, what is sacrificed are transactions. So transactions are limited. Transactions in HBase would work for a single row only. But the advantages are such that HBase can handle data in a range of several petabytes, and it provides excellent performance of millions of queries per second. HBase has its origin in Google technologies, particularly in the system called Bigtable that was described in a paper in 2006. Google has its own internal implementation, and the HBase follows these ideas and implements them in Java on top of Hadoop. Some of the features of HBase is that it is built on top of HDFS, and as various other columnar stores, it provides for very good compression. It also can deal with in-memory column families, and that provides us with significantly improved speed if our data can fit into the memory. Some of the other interesting design choices, inclusion of so-called Bloom filters, which is an approach that can provide us with a very quick resolution if an element is member of a set or not. We have also features for bulk loading. Zookeeper, the system that we have seen in previous section, is acting as the coordinator for the cluster. And we can involve HBase tables as input and output for various MapReduce jobs. So you can see that HBase has a great set of advantages over traditional Hadoop and the MapReduce that we would run on it. Let's see how we would run and use HBase. During development, you would typically run HBase in a local mode. This will enable you to have really good response times, convenient for the development, and then later you can deploy it on the cluster. You have a command language interface. Primarily, you will be using Hive from APIs that exist in various languages. They tend to be fairly low level, they're rather primitive. HBase on its own does not provide any query language. But there is a set of projects that are including HBase and SQL and putting them together. One notable project is Apache Phoenix that is giving us SQL on top of HBase. Let's see what is the HBase data model. We have the concept of so-called column family. That is close to table that we have in relational database. The data structure is a sparse, multidimensional map. And the model is such that we have a triple of a row and column. You can think of those as coordinates. And in addition to that, there is a timestamp. This is something that we call a cell. And that is interesting that we are storing the timestamp. That gives us possibilities to run queries in which we can ask, how did the data look like at a particular point in time? Then we have regions, which are contiguous sets of lexicographically sorted rows. They are basically representing a unit of scalability in the system. We mentioned that systems like HBase often do some trade-offs, and one of the trade-offs in many of the NoSQL distributed stores is that don't have joins, so HBase belongs to this category. Now the question is then, so how are you going to use such a system if you don't have joins? Well, the common workaround or even a recommended approach is to denormalize everything. And it is perfectly acceptable in such designs to store data in multiple places. Remember that the primary enemy that we are fighting here is lack of performance for very large data sets. So we will be willing to sacrifice the efficiency of storage, have our data stored multiple times, but then when we need to access this data, we will be able just to go there and read it without doing any joins at the read time. And naturally, this will require you to be very careful when you are designing your schemas. So one of the typical things that you would do for a model like this is that you would decide what should be the queries that will be running over this database, and then you design your data model that everything that you need to answer a particular query is stored in one table. So you just need to go and read. You try to avoid doing any additional work at runtime. Anything besides read is not considered to improve your performance. And we have mentioned that there is this data structure called Bloom filters that provides us with very quick responses for misses. So if the key is not in the system, we hear about that very, very quickly. Tables and rows. A table can naturally have many rows. Each row has a primary key, and HBase is not choosy about your keys and data in general. So a key is just a sequence of bytes. For a row, we can have an arbitrary number of columns. And a column is also just a sequence of bytes. So you can see HBase does not have any notion of data structures or primitive types. Everything is just a sequence of bytes. And internally, the rows are sorted. All the data is versioned and timestamped. Column families are providing us to organize our columns. And they would be similar to things like records and objects. Basically, one column family is going to provide us for a unit of access, and we don't need to access or load the data that is not used. So basically what we do here, we are minimizing the data movement, and we can design our system so that the related things go into the same column family, and that will give us performance advantage. And then the other things that you can do with the column family is you can define various settings like compression, version retention policy, or cache priority. Regions are subsets of rows. They will be automatically sharded, and they would be acting similar to range partitions. So they enabled us to also more efficiently design our system. The API that we have for HBase is rather simple, and normally we would use it from Java programs. And it provides a fairly low-level operations like get, put, delete. We can scan for values, increment column value, and we have also MapReduce as a source and sink for our data. So fairly low-level API. You would typically use them from the Java programs, but you should also consider looking into Apache Phoenix that provides us with an access from SQL, and normally in programs then you could be using a JDBC to access the HBase data.